This project is a CSTEPS project, the Collaborative Sketch Tools for Engineering Problem Solving. In this project, we're really looking at how do you create sketch tools on interactive surfaces such as tables or tablets to support students when they're working in groups in introductory engineering classes. So what you're seeing in this video here is students actually pilot testing some of the software that we've built for a research study that we'll be conducting in a few weeks' time. This will allow me to really understand how the technology is supporting the collaboration within groups of students, and also how the teaching assistants are using the technology to support between group conversation and sort of whole class wrap-up conversations at the end of the tasks.
In this lab, we're doing a bunch of different kinds of investigations, and one is looking at these large multi-touch screen tables versus tablets. The tablets are a much cheaper way of implementing technology in classrooms, and certainly that's happening in classrooms today. I think we're at the intersection of how do you use these technologies and what are the best teaching practices, and perhaps in this lab we can not just learn about the technologies, but how we implement the technology in a classroom setting.
Conducting this research in IDEALL allows us to collect data on all the groups simultaneously while they're working on this activity. Rather than bringing numerous cameras into their classroom, we get to bring the students into our lab space and the cameras just roll easily. It means the cameras are not in the students' way, they're not terribly aware of them, so they can get on with their normal work, and we can collect much higher quality audio data than we could do in a typical classroom. We have a lot of research that tells us about how groups work with technology in small groups, but we know a whole lot less about how we implement it in classrooms. So that's what this work is going to allow me to do.
I get to do as a graduate student here at the College of Education is work in the IDEALL lab. And it's this new technology space where we get to bring real learners into a real classroom setting and then investigate how they work in collaborative setting. I have a particular subject interest in science, and many of us that work in this particular space work in all different kinds of disciplines, from engineering to social sciences. I'm working with middle school students next semester that will actually come into the space and investigate climate change activities using these new technologies.
When they've been and we've collected all this video data, we'll spend a lot of time analyzing it to understand how the technology is influencing the collaboration and the learning, and then start changing the software, and next year we'll bring them in again and try it again. So this sort of iterative design activities, by the time we actually are finished the project, the technology will be really usable for classrooms.
We're really interested in how people collaborate and work together to solve problems. And why that's important to me, coming from a science perspective, is that science is an interdisciplinary problem. And it involves math and engineering and science, and things like climate change aren't going to be solved with one scientist in one discipline using one tool set. So these technologies really help us integrate knowledge and consolidate knowledge and really, I think, mimic how people solve problems in real life. So that, to me, makes what we're doing here, even in this very experimental space, really applicable and really real, and it gets me excited about being here.